All right, friends. 1.5. Can you state and apply the ruler, protractor, and angle addition postulates? Can you use coordinates to determine distance and classify angles by their measure? Okay, so the ruler postulate just kind of gives a postulate to what we talked about in the last section. Every point on a line divides the line into 3 disjoint sets: the point and the 2 half lines. Okay, so A divides this line into point A and half line. We'll say there's a point down here called Z, and we'll say there's B's up there. Half line A, Z, and half line A, B. So those are your 3 disjoint sets: point A, half line AZ, and half line AB. All right, so here's a couple more definitions that we need to have within our little vocabulary book. Coordinate. A coordinate is a point on a number line or graph coordinate that corresponds to that point. Lowercase letters are the coordinates. The point is represented by an uppercase letter. Okay, so if we had a coordinate on a grid and it was x comma y, that would be the coordinate of it, but the point, it would be point Q, or whatever we designated for that point. Length. Length is the distance between its endpoints on a number line. The length of segment AB is equal to the absolute value of A minus B. Since it's a distance, it's always positive. Remember, absolute value is a measure of distance. And when we talk about length, we're talking about distance. Okay? So let's look at example number 1 here. It says find the length of each segment. So we have segment BD. We need to find the length of BD. So that's going to be equal to the absolute value of B, which is -5, minus D. D is 1, 2. So that's the absolute value of -7 or 7. Okay, so the length from B to D is 7 units. And we can verify that or check that if we just even look at the line graph. If we move 1, 2, 3, 4, 5, 6, 7 from B, we get to D. All right, so let's find the length of AE. So the length of AE, A is that, let's see, that's -5, -6, -7, -8. So that's -8 minus E is at 2, 3. So that's the absolute value of -11, and the distance is 11 units. Once again, you could count if you wanted from A to E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we'd get to E. Now, that's fine when it's a small number line like this, but you would not want to do anything when it gets really large. That would be a pain. So use the subtraction method, where you're subtracting one point from the other point. So let's look at C. C is EC, which it wants us to do EC. Now, I just want to let you know this, and I want you to see what I'm doing here. C is at -1. E is at 1, 2, 3. 3 again. 3. Now, a lot of students will go, whoa, 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 whoa. It says EC. Well, let's look at it if I wrote it EC. So E is 3 minus C is -1. Oh, that says 3 plus 1. Mine that I set up was -1 minus 3, which is -4. This one over here is 4. But remember, we're doing absolute value. The absolute value of -4 is 4. The absolute value of 4 is 4. So the order in this case doesn't matter due to the fact that it's absolute value. Okay? So just understand that. You may see a little discrepancy there. Now when it comes to when we're doing distance formula, there is some order that matters, but we'll talk about that when we get there. All right, next two definitions. Congruent segments. Congruent segments are segments with equal length. This symbol right here, indicates your congruence. So make sure you understand this congruence. They are different, but the same. Okay? These two segments, AB and segment CD, are congruent. They are different segments, but they are the same. Between, we already talked about between, but this we are going to define that if B is between A and C, then AB plus BC is equal to AC. This is the main part I want you to remember, okay? You need to kind of star that, highlight it, do something, because you're going to see that coming up. Okay, so let's look at example number 2 here, and I know it looks a little funny on my page. Technical difficulties, but I learned to get over it. All right, so here's the problem. Find segment AB and segment BC if the total segment of AC is 75 units. If we don't know what it is, we're just going to say units. Because remember, this is geometry. We're talking about physical measure most of the time. So if it doesn't say inches or feet or centimeters, I'm going to say units. So here's our problem. Well, we know that segment AB plus segment BC is equal to the total segment AC. There are my segment markers. All right, so let's plug in what we know. We're just going to plug it in, plug it in. We know AB is 6x minus 1, okay, because it tells us that right there. Plus BC is 5x plus 10. And then we know that the total AC is 75. Now this just becomes a straight algebra problem. 6x plus 5x is 11x plus 9 equals 75. And if we continue to solve for that, we have 11x is equal to 64. And, 66. 66 divide by 11, so x is equal to 6. So looking at the question though, we right here have found x. Please always go back and read the question before you are done, because the question says find AB and BC. So now what we have to do is plug 6 in. So that becomes 6 times 6 minus 1. Okay, or minus 1. So that's 36 minus 1, or 35. So the length of AB is 35. Again, right here we've got 5 times 6 plus 10. 5 times 6 is 30 plus 10, which is 40. So your two lengths that you found are 35 and 40. All right, so that gives us example 2. So moving on, we now are going to talk about midpoint. We've talked about the word between, which just means it is between 2 points. Something is between 2 points. But now we're talking about midpoint. And midpoint states that M is between X and Y, and, okay, look at your kind of conjunction here, and that XM is equal to MY, or that should be segment XM is congruent to segment MY. Okay, so that now means it's between, but each segment is equal. Okay, so hopefully that makes a little bit of sense. So let's continue moving down. So the protractor postulate tells us that any angle A can be placed in a one-to-one correspondent with a degree measure less than or equal to 180. Here's what that says in fancy words. Here's what that says. It just says that you can measure angles, period. But an angle has to be larger than 0 degrees and less than 180 degrees. You can have a 180 degree angle because it's less than or equal to. Hopefully you noticed that. But a 180 degree angle is a straight angle or a straight line. 1 degree is defined as 1/60th of a complete rotation. Okay? The measure of an angle is a number, while the angle is a set of points. So when we are writing in geometry, if I'm asking you to give me the measure of angle B, you're going to say the measure of angle B is equal to 36 degrees. If I wanted you to write angle B is congruent to angle X, you would not write the measure, you would just write angle B is congruent to angle X. Okay. Angles are classified by their angle measurements. This should be repetition to you, so I'm going to go quickly. You have acute angles, which are between 0 and 90. You have right angles, which are equal to 90. And you have obtuse angles, which are 90 to 180. Again, remember I said earlier, you can have an angle equal to 180 degrees, but that is something we call a straight angle. All right, so let's look at example 3. Example 3 says find the measure of each angle. Oops, there we go. Find the measure of each angle, then classify the angle as acute, right, obtuse, or straight. So I'm going to be using my highlighter. I strongly suggest when you work problems to always kind of, if you can, either copy the figure onto your own paper and mark up your figure, or use a pencil or lay a piece of tissue paper over it so you can actually manipulate and draw on your figure kind of like I'm doing. Okay? All right, so let's look at BAC. BAC, that's this angle right there. If I'm reading my protractor, that angle is 60 degrees. Now we're going to talk in class on actually how to read the protractor, okay, because I feel like a lot of times that students don't know how to read a protractor, they get confused. So I'm going to make sure we know how to read protractors. So once again, like BAC is 60 degrees. 60 degrees. And then it says classify acute, right, obtuse, or straight. So that's going to be acute. The measure of angle EAB, again right here, EAB. Oh, so this is larger and it's opening up toward the left. So we're reading the top numbers. So that's 120 degrees. And that's obtuse. And last but not least, let's look at BAD. We have BAD. Now that one is a little bit different. If we look at the way this problem or the way this angle is sitting on our protractor, it's not quite normal. So it goes from 30 to 120. Well, if we take 120 degrees and we subtract 30 degrees, that's right, 120 minus 30 is 90 degrees. So this is a right triangle or a right angle. Okay. All right, so a couple more definitions. Congruent angles are angles with equal measures. Adjacent angles are coplanar angles with a common side, but no common interior points. Your angle addition postulate is one you will use quite a bit in proofs. The angle addition postulate states if K lies in the interior of M and P. So let's draw this. Here's M and P. Now it doesn't matter if my M and P are switched, it's okay. And if K lies within the interior, so here's my point K, then the angle MNK, the measure of angle MNK, plus the measure of angle KNP is equal to the total measure of the large angle MNP. It basically says if you take angle 1 and you add it up with angle 2, it gives you the entire large angle. So let's look at example 4. It's going to show us this. The measure of angle 2, it says find the measure of angle 2 and the measure of angle BAD. So I want to find the measure of angle 2 and I want to find the measure of angle BAD. If the measure of angle 1 is 55 degrees. Now, one thing we have in this image right here are these little markings. These little markings right here, I call them rainbows. You'll see them marked differently in different texts, and I'll show you some other ways to mark later. But those little rainbows show angle congruence. What that says is since angle 1 has a double rainbow and angle 2 has a double rainbow, it means that those angles are congruent. So, since the measure of angle 1 is 55 degrees, the measure of angle 2 is also equal to 55 degrees. Now, since the measure of angle 1 is 55 degrees and the measure of angle 2 is equal to 55 degrees, we know the measure of angle BAD is going to be equal to the measure of angle 1 plus the measure of angle 2. If I put some substitution in there, that's 55 plus 55. That gives me 0, 1. So the measure of angle BAD is equal to 110 degrees. Okay? All right. A lot of definitions in here. Be comfortable with this new vocabulary. This is where you need to get comfortable. Remember to fill out that TRF, highlighting any questions or places of concern that you may have run into while watching this video. And I'll see you when we go over 1-5.